Hi, welcome to the third lesson in my series on revising grades 6 and 7 for GCSE. Throughout the lesson, I suggest you read and try each question by pausing the video before the timer runs out. The work solution will then appear so you can check your work. If you find this video helpful, please hit the like and subscribe button below so you never miss a lesson. Many thanks, and I hope you enjoy the lesson. To solve this equation, we need to cancel out the divisions of 2, 3 and 6. So to do this, we're going to multiply everything by 6, which is their lowest common multiple. So we have 6 lots of x over 2 plus 6 lots of x plus 3 all over 3, which is equal to 6 lots of 1/6. So the 6 divided by 2 will cancel to make 3, so 3x. The 6 divided by 3 will cancel to make 2 lots of x plus 3. And the 6 divided by 6 here will cancel, so we have equal to 1. So now we can expand the brackets out, so we have 3x plus 2x plus 6 is equal to 1. We can collect these like terms together, so 5x plus 6 equals 1. We'll take away the 6 from both sides, so 5x is equal to minus 5, and then we'll divide both sides by 5. So x will equal to negative 1. To rationalise this denominator, we need to cancel out this root 2. And we can do this by multiplying both the numerator and denominator by root 2. So now we have 8 root 2 over root 2 multiplied by itself, which is root 2 squared. And the square root and the square will cancel, so this root 2 becomes rational. So now we have 8 root 2 over 2. We can simplify this fraction, dividing both by 2. These 2 will cancel, and the 8 divided by 2 will make 4 root 2. So we've been asked to work out the length of x in this right angle triangle. And we're going to use Pythagoras' theorem, where we have 5 squared plus 5 root 3 all squared will equal the area of a square on the hypotenuse side, so x squared. So this 5 squared becomes 25. The 5 root 3 is 5 times 5 times root 3 times root 3. These will make 25, and the root 3's will cancel, so we'll have 25 times 3, so 75. And this will equal x squared. 25 plus 75 is 100. This is x squared. We can take the square root of both sides, so x is equal to 10. We know it's not negative 10 because x is the length. We're going to convert 0.315, where the 1 and 5 are recurring, to a fraction. So we're going to split it up into 2 decimals, one which is terminating, so 0.3, and one which is recurring, so 0.015. The 0.3 we know is 3/10. To work this out as a fraction, we're going to say let x equal 0.015 when these are recurring. And now to move up the 1 and the 5 to near line, we're going to have 100x, because this 1 will move 2 places, this 5 will move 2 places, and then we'll have a 1 over 5. So this becomes 1.5, 1.5, 1.5, and so on. So now we need to eliminate the recurring 1s and 5s, which we can do by finding the difference between the two. So this will be 100x take away 1x, so 99x. And these 5s will eliminate, as will these, and these, and these. So we're left with 5.1. So 99x is equal to 1.5, we can divide both sides by 99. So x will equal 1.5 divided by 99. We can make the numerator an integer, so x will equal 15 over 990. So now we can add this fraction with this one. So 3/10 added to 15 over 990. We'll use an equivalent fraction here, multiply this by 99. So we get 297 over 999 plus 15 over the same denominator, and this gives us 312 over 990, which simplifies to make 52 over 165. We're going to simplify this addition. So to begin with, we need a common denominator. So we'll multiply this fraction by 5x and this fraction by x plus 1. So we have 3 lots of 5x over 5x lots of x plus 1 plus 2 lots of x plus 1 over 5x lots of x plus 1. So now we have a common denominator. We can simplify our numerator. So we have 15x plus 2x plus 2 all over 5x multiplied by x plus 1. We can simplify the 15x and the 2x to make 17x plus 2 over 5x lots of x plus 1. So this is our simplified fraction here. To factorize question B, we need to take out the highest common factor, which in this case is the 5, which goes into 10 and 5, and the a minus b, which goes into a minus b squared, and a minus b. So we'll take out 5 lots of a minus b, and then we have 5 times 2 to make the 10, and we need another a minus b plus the 1 to make this side. So now we can tidy up the square bracket. So we have 5 lots of a minus b, and then this becomes 2a minus 2b plus the 1. So this is now fully factorized. And for question C, we've been asked to work out f of minus 3. So this means that the x has been replaced by negative 3. So we'll substitute this negative 3 in place of the x here and here. Then this becomes 2 lots of negative 3 squared plus 3 lots of negative 3. Negative 3 squared is 9, so this becomes 18, and 3 times negative 3 is negative 9, so f of minus 3 is equal to 9. We've been asked to work out the total surface area of this cone, and we've been given the formula for the curved surface area, which is pi RL. So this is this area here. But the total surface area also includes the base, and the base is a circle with a formula of pi r squared, and that is this area here. So the radius is the same as the radius of a cone. So to work out the total surface area, we're going to add together pi RL, the curved area, plus the base, pi r squared. So we have pi times the radius, which is 10, times the length of a slanted height, which is 15, plus pi times the radius of a base, 10, which we'll square. Then this becomes 150 pi plus 100 pi, which gives us a total area of 250 pi centimeters squared. So for part B, we've told that the second similar cone at a surface area, which is 25 times the surface area of the first cone. So we'll write this as a ratio. So the second cone as an area 25 times that of the first cone, so the ratio is 1 to 25, and this gives us the area scale factor. So to work out the length scale factor, which we need for the radius, we need to square root the area scale factor. So this will be the square root of 25, which is 5. So now we can write another ratio now, but for the length scale factor. So now we have 1 to 5. And we've been asked to work out the radius of a base of a second cone. So our first cone has a base or radius of 10 centimeters. So our second cone will be 10 times 5, which is 50 centimeters. We've been asked to work out angle O to D to A, which is this angle here. So to do this, I've sketched a triangle OAD, which is this triangle. And because O to A and O to D are radii in the same circle, these are equal. So this is an isosceles triangle. So now we need to work out either this angle or this angle. And we can begin using corresponding angles, which is this 36 is equal to this angle here, because they are corresponding. And we also know that we have a tangent and a radius. So this angle is 90 degrees. And next, we can work out this angle because we have a right angled triangle OCD. So this will be 90 minus the 36, which is 54 degrees. So now we have the 60 degrees here and the 54. We can add these together to get angle AOD, which is the same as this one. And this is 114 degrees. Finally, we can use base angles in an isosceles triangle to work out this angle. So this will be 180, take away the 114, and because these two are equal, we can just divide this by 2, and this will give us 33 degrees, which is the angle we're trying to find. In this question, we've been asked to work out how far she had run over the 19 seconds. So because we've been given a velocity time graph, the distance covered is the area underneath the lines. So this is this area here. So we need to work out this area. And you can see why this works. Because if we think of area as a product of velocity, meters per second, and time, which is seconds, the division of seconds and the multiplication will cancel. So we're left with meters, which is a measure of distance. So to work out this area, I'm going to split up this graph into 4 different shapes. We have this triangle, this trapezium, this rectangle, and the final triangle. And I'm going to sketch these 4 shapes separately. So to work out each individual area, we can multiply the base of a triangle by the height and then divide it by 2. So this will give us 12 divided by 2, which is 6. For trapezium, we can halve the sum of the parallel sides, when these two sides are parallel. So this will give us 6 add 4 divided by 2 times the height of a length of 6. So this will give us 30 meters. The rectangle is 6 by 5. This is also 30 meters. And the triangle is 6 times 5 divided by 2. So this is 15 meters. So the total area, or the total distance covered, is the sum of these areas. So we have 6 meters plus 30 plus another 30 plus a 15. So in total, she has covered 81 meters.